So one colleague said that we will have to clean the data to remove, let's say, unnecessary characters, garbage stuff, and things like that. The other thing is will be needed.
So the model could understand
Understands in numbers.
Yeah. So usually, as we discussed in the first two sessions, for computer, it's easy to understand the number. Text is also represented in here, but there were two parts that I mentioned. One, dimensionality reduction. Dimensionality reduction, as I mentioned, that for example, from text, we change it to an array of numbers. So when you are comparing the things, it's easy to find the distance between two numbers. Okay, that's why we say that vectorization is. After the vectorization, okay, what do you think? Like when it's vectorized, what else will we need? What will be the next step? You get your data, you bring it to the cloud, you transform it or clean it or vectorize it. What happens next after that?
So we will embed it.
Okay, yeah, good. And after the indexing, what we will do next? What do you think? Like when it's vectorized, what else will we need? Use that data. Like what is the interface like? How would you make it available to the model?
We will embed the data. Embedding.
Okay, embedding is the vectorization that we covered. Now, we have to get that thing. So if I just put in here, do you guys
however many use cases we have.
okay? Anyone else? Great.
Identify data types, might be images, audio, video, text.
Great, because we discussed there can be different types: text, image.
However many use cases we have.
When, for example, something happens or they update it, how you will bring that back to the cloud? Because something changes here, you want to bring that knowledge back to the cloud, right? So this is not exhaustive, but I just like give you the key point. You need to know the location, okay? The location of the data is located on your website, let's say, or on, let's say, Wikipedia as an example, or you have your own files or your HR policy, you need to know that. And then maybe it's available on SharePoint or content management system or database. You need to know from where to pick the data. Okay. Then the format we already discussed, the size, the format, what you need to do on this. So you can understand what are the next processes you have to do. Okay. And the thing is then when you are bringing it, you have to think about a technology that can bring this data from your other sources to the cloud. It might be in the cloud, but you have to bring it some way to another model. So if I just focus on that for ingestion, what do you think we should be using for ingestion? Ingestion means that you need to connect to the source, you need to connect to a target, which is like the cloud, and you need to bring that data on a particular frequency. The frequency means you want to refresh it every day, every month, every hour, every 5 minutes. When something got updated, you want to bring it. So if I call you, is there any tools that you can think about and tell me that these are the tools which can be used for ingestion?
API? API?
Maybe APIs, yes.
That's scheduler with combination of API.
Yeah, scheduler, you have to do a scheduling on something, right? So let me go to the next part, okay? So some of the cloud application which we normally use, okay? This is not exhaustive list, I'm just giving you an example, okay? Usually, you need to have an orchestrator which you can call it on particular frequency. It can be either time-based or event-based. Time can be meaning that, for example, you know that every hour or every day something will get updated. So you want to bring the fresh data. Okay, this is the timer base. Event based means that something changed. Either a new file is there, or you want to say that, for example, when an update happens, you got some triggers. Okay, that's another mechanism. So there is, I've given two main application, which is a SaaS, like a PaaS service in Azure, Logic App and Data Factory. This has built-in connectors for SQL Server, Oracle, SharePoint, email address, SuccessFactors, SAP, all these 100 different connectors. So you don't have to write anything new for your own site. You just need to connect to this, and you just say that, for example, based on timer or event, I want to bring that data to the cloud. Okay. The custom application, whether it's to an API, sometimes the data source will not give you as an open protocol. They will create an API on top of it. So you need to connect to an API. The APIs can be called from these services as well. Okay. If something is failed, you want to send an email. If something is done, you want to like alert someone so that this orchestrator can help you do all these things out of the box.
Let's suppose I have a statement, okay? Inside one token is updated. So I need to update only that token or the whole statement.
Yeah, very good question. So usually, if you know that we were discussing about chunks, okay? If you remember, like that whenever you are creating a vectors, you have to take that chunk or that and the vectors will be updated. So even if a single word is updated, either you need to know which chunk is updated or which document is updated, or if you don't know, you cannot like to identify the changes, you also have to do a lot of processing. So by default, if your data set is not large, you just bring everything again. But if your data is very large and you just know that this source has updated, you just update that particular records. Okay.
So we're talking about the data set is already uploaded and we change something that's already there.
Yeah.
So
consider that you have an HR policy. Okay. Let's say your leave policy. It is available, let's say in one page, one chunk. You have updated it in your target with a vectorized database. Okay. You cleaned it. But consider your HR policy has changed. Now, what you will do, you might not have just one HR policy. You might have 100 other policy. So the question was whether we update all the policies, all the chunks, or just one of them.
text them or maybe like by the day they were uploaded or
Yeah,
something.
you have the mechanism to do one change or the whole change. It is about the things like, for example, to identify the change, you also have to do some processing. You need to know which one has changed. If you know exactly that one has changed, you can do that processing as well.
If I let's say that I updated day and I know that the last time I uploaded is like on day 5 and I uploaded until day 7.
Yeah.
So I have 7 days. Can I just index it based on day 5? So now that I made that change, I know that I made that change on day 5, so I can just update the data for day 5 only.
Usually the data will be on the, like there will be only one version on a target, the latest version. Okay, you will have timestamp when it was updated. You will have the logs and everything. But usually the statement that you want to say, don't show the older data or the older knowledge to the end user, because they don't care if the knowledge is updated. You just want to show the new stuff. Okay, but if your use case is such that you have to show multiple versions, then you can do that as well. Okay. Okay, so from this one, I'll just show now the snapshot how it will look in the cloud, and then we will go to the next part. Any questions on this one before I show the architecture piece for this part? So this is how it will look like. Consider that you have, let's say, one information which is on your website, okay, your SharePoint, your files and everything. You identify that these are the sources, these are the types. So consider that you're just considering as for your use case, just text file as an example, okay? We just say that there will be an ingestion pipeline and you need to store it in the cloud. Why I selected storage account here currently? Okay, why I selected here, why I didn't put it directly on a database or a vector database? I just put it as a raw file on a storage account. And a storage account can be considered like your C drive. It is just a drive where I can put any type of format in the file. So why I selected a storage account here and not a database?
Because it's unstructured.
Yeah, because you need to have the copy of the source in one form so you can cross-check as well. When you are doing something updates on the database, you want to match it to the source. You cannot always go to the source directly. You need to have a copy of the source in there. This is what we call a raw data. So you bring the data as it is to the cloud. So if somebody else tomorrow require this data, you don't have to go to again to this data sets. You directly go to the storage account and provide the feed from there. Okay, makes sense? And this line is what the tools I was showing previously that you use one of them. Okay, and you schedule it. Make sense till now? So this is the first point we have to do. Now, what we discuss after this, the second point was what we need to do with this data. This is the raw data now we have brought to the cloud. What do we need to do next? We already discussed in the first part. So let's go here. Okay. So we covered here. Now what we need to do? Index or clean or transform or vectorize. Okay. So we'll go to this part now. So let's see what are the tools here. Can you tell me what are the tools that we have checked in the previous thing? What are the different type of vector databases that we talked about in the previous sessions? Postgres, Mongo.
Can use ESP and ASN.
Yeah. So multiple options, right? We discussed there was multiple option. I just say you have structured databases, which can be an SQL database or Postgres database. Okay. Then you have NoSQL database, which we cover Mongo. We covered Cosmos DB, we covered Redis. And there was one other service which we call AI search. And I mentioned that this is usually for different parts, like you can have vectors as well as text-based similarity searches as well. Okay. So if I go back to this one, okay, these are the different vector databases. This is not exhaustive list. Okay. I'm just giving you the options that we selected. Okay. So if you see here in MongoDB, we have two options. The SQL interface or database and the Mongo vCode. They are both part of the Cosmos DB. Okay. Then we have Postgres. Postgres has two flavors. One is called Flex Server. Okay. This just I'm giving you some names. Okay. You don't need to remember it, but I'm just giving you how many options you have. Okay. And can you tell me why cloud is providing so many options? Like why not stick with one? Can you tell me why Azure is providing 8 different options for you for the same type of functionality?
Legacy code maybe.
Okay.
Legacy code.
Yeah, that can be one thing.
Case and infrastructure what we are using before.
Yeah, maybe that's also like correct.
Attract more customers and gain more money.
Yeah, that's really good because if there was only one phone, let's say iPhone or Samsung, right? You have a monopoly. And you want to give the things, some people say that I want to go with open source databases. Open source databases, you have open source databases. Okay, this is open source. If they want to have like a structured databases, you have structured databases as well. If you want to have like Mongo, it's about the like the persona, the use cases. So you have so many options based on your own use case. You can select one of them. Sometimes you will require multiple of them together. But I'm just giving you the option that you have structured, unstructured, open source, Microsoft proprietary, all the options available for a vector database. Okay. Now we'll discuss that there will be two parts. We need to index the data. Okay. This will be a bit, I covered it in the first session and the second session when I was building the pipelines and the code and the Python. Okay. But I'll just go to the next part. You guys understand that we have to now take the data and vectorize it and clean it, right? And I have to select one of these Lego pieces in the architecture. So I'll build the architecture and then I'll explain it again, okay? And you have to help me whether this makes sense. Now you see two parts, okay? This is the first part we all understood, right? Now I need to ingest, okay? I'll just show two parts. I have given two parts, one on the top, which is cognitive search or AI search. And here I have given like the vector databases, multiple options, okay? Now you can see on this one, let me start with the lower part. The database in itself has just a compute, but it doesn't have any processing power in itself. I have to have, like the database cannot do the image to text conversion or image to vector conversion out of the box. Okay, it needs some other components like a code. Azure function is just considered like a compute, which you run some code and it's doing some transformation. Okay, so if I need to put or vectorize the data, we discussed first we need to clean the data, right? Remove the stuff from the file. Maybe once I clean it, I put it back on the storage account. Okay, because you will not have the clean data. You don't need to keep it in the memory. If you need to do that, you can just validate it and you can always refer back that this was the file, the clean file which I took. Okay, and then afterwards you do the vectorization. The vectorization means you insert it, okay, in the table, in the form after the chunking and everything. You can add the chunking mechanism and everything, but just consider there is some compute which is processing the data and then putting it into a vector database. Okay, we also check one thing that you can do the vectorization within the database. I showed one example in which I need to trigger. I created a table and I give a link of that table. Whenever a data is inserted, it automatically creates the vectors. Which database was that? Postgres. So Postgres, I created a trigger, and whenever a table was updated for the row, it automatically created the vectors of this. Okay. Now, if you see the top part, okay, this AI search, okay, has a lot of built-in functionality. Built-in functionality. If you want to do like text to like translation, or you want to extract keywords of images or OCR and everything, in here you have to write the custom code. In here, it's already built in these services. Okay. So, for example, you can ingest the images and tell them what is in the image or what is the metadata in here. It will automatically extract it out for you. You don't have to write custom code for you. So if you want to write less code, you can do this. Okay. Then, for example, if you want to translate the language from one to another, or you have images and you want to do OCR on top of it, this will automatically provide OCR capability. Okay. So the top part, if you see, built-in skills. Built-in skills mean that it has automatically this functionality. I just have to link it. And then if you want to enhance it, okay, there is custom skills. Custom skills means that I have to call some other services. So what you do is you attach the other services to it, and when you are ingesting the data, it would automatically do it. But essentially, if you see here, it just says index and vector. The output is here as well, index and vector. Okay, so you have these 4 or 5 options. You just need to select one based on your use case. Okay, if you remember, I show you a matrix on the second lecture, if I remember correctly. Okay, I said that this provide a text speaks and vector search both, and these are usually vector search. Okay, but just understand that sometimes the vector will not give you like a keyword-based search. The upper one combine both. It's a Lucene-based search, and you can combine both together. Okay, questions on this till now? Does it making sense that we are building it together and you are agreeing that this should how it should be looking like? Okay, so going forward, I will just concentrate on this one, that we selected this one, and we will just take the arrow forward from this. Okay, you have the options, you can do anything, but we will just go in here.
What is document cracking and enriching?
Yeah, so consider that document tracking, you want to do chunking on your like from this. So just consider the chunking is built in the service.
That's the document cracking.
Yes. Yeah, and also a document like PDF to text, or images to text. This is like doing the cracking as well. It's automatically doing that and converting it to text. Okay. Images, when you are doing it, if there is celebrity images, it will automatically identify. It will say this is Bill Gates, this is Steve Jobs, this is this person, this is fruits, this is vegetables, and things like that. So it's doing understanding on that based on the vision model. It is doing the cracking. Okay, and also like applying this to create the vector graph. Okay, making sense till now?
Okay.
Question over here.
Yeah.
There's one question from online asking if SQL DB be used as a vector database.
Yeah. So this is what I showed here. SQL database can be used as a vector database. This is on this one. So you have these options. If you see the last one, that's SQL database, and there is a YouTube session by the product group as well. Okay, and you can listen to that how to do the vectorization in SQL database as well. Okay, and almost all the databases are now upgrading to include vector databases inside them. Okay, all good till now? What should we do next? What we agreed on? Okay, let me go back. We have to build the application, right? To retrieve the data. So what are the information you are aware of? Is there any, how can I host the application? What type of compute should I use? Any idea?
Here our function.
Yeah, function is one, like we use here as well.
Service.
They have services, yeah. What else? Open source, can you tell me anything open source? On the application side, where can I host the applications? On open source technology in Azure, if you know.
Clusters or something.
Yeah, AKS, great. Yeah, so very well. I think you guys already know this. People who are not aware of this, okay, we will just go here. This one, I'll come back to this one, okay? So these are some of the you want to host a code or application. Okay, these are the different options which you can run on. Okay, again, multiple Lego pieces. If you are using open source, you want to use Microsoft technology, you want to run Python, C#, JavaScript, whatever options you have, you can run it based on your use case. Okay. Now, anyone know what this terminology is? That ARO. Okay, Azure Red Hat OpenShift. You can use it as like if you want to use OpenShift, you can use that as well. Okay. So this is where you yeah.
The purpose of the application. So we have the data, then we clean and factorize it. So what does the application's part?
So consider the application. Good question. If the application is not there and you ask a question, what will be the orchestrator of the application that should retrieve the data, process it, call the model, understand the history, and then respond it back?
The application is like a middleman, right?
Orchestrated.
Yeah.
Between the data and maybe an LLM model.
The user. Consider the user. Okay. So consider that this application is you ask a question. Okay. Who is Bill Gates as an example?
Okay.
Okay. It needs to first do the step. If you remember from the first one, it has to first vectorize this question as well. Then it will go to the database, try to find what is the closest match of this knowledge, retrieve that knowledge, bring it back to the function, call the model again that now respond back, and then the respond back to the user. Okay, so this is the function of this compute. Okay.
We also have the flow in the architecture. We'll be showing you like towards the end of the session so that you will see the components and the interactions between them, so that you will see actually what orchestrator is doing in contacting which services together what.
Yeah. So now in here, you see the question. Let's say the question is coming. You are asking the question, who is Bill Gates? Or what is my HR policy? Or how many leaves can I have? Let's say we have built that HR scenario. Okay. Please, yeah, there will be seats here, and yeah, there are 2 seats here in the middle as well. Okay. So consider that this is we hosted on Azure function. And Azure function is usually if you have a simple code, okay, a simple code which is just like calling one unit of work. Okay. So consider that you have got like the question. First, it will go to the OpenAI model and create embedding for the question. Then what it will do is it will call the database to find the closest matches based on the vector similarity. Okay. That result will be coming back here, and then it will call this one to complete the answer. Complete the answer means what should I respond back to now? The question and the knowledge will go together, because if you remember, I told you OpenAI is a stateless service. It doesn't have any memory. You have to put everything knowledge in here and just say that now tell me this answer. It will do that and respond back. If you want to use anything translation like Arabic, English, and things like that, you can do it directly in OpenAI. But if you want to use like the other service directly, which is called translator service, you can do that as well. Okay. Does it make sense till now?
Yeah, small question. When it comes to like these out of the box options, how accurate are they? Like if I want to use a translator, how much should I rely on it, or should I maybe consider other options? Maybe.
Yeah, great question. It's again like very debatable, right? Based on the use case, you have to try it out whether it's making your scenario or not. Most of the time it works. Sometimes you have to use another service, and that is based on the use case. I don't know. Like most of the time it works. Sometimes what we do is that if you do the intent detection, like if you remember in the second lecture, I just said that if you have one application which is creating 2 different services, let's say that you are a company who is providing, let's say, booking airline tickets and also selling pizza. Okay. And the question is to book me a flight. How would you know whether the intent is to book a flight or to order a pizza? Okay. So you need to first identify the intent. Okay. The intent you can create like in OpenAI model that you identify the intent. These are 2 intent. And there is a separate service as well. That is the intents can be identified there as well. Based on the latency, you can find out which one is more useful for your one, and you use that model. Okay. Question? No questions? No? Okay. So we built till now the architecture. So can you tell me now what is missing? Like if I completed this one in the original architecture, let's say I've indexed the data, I've created the application. There is one thing which which you think is missing or not? Like what should I do? Like for example, if I ask you a question that how effective is your chatbot? or how effective is your response? How would you, is this architecture cover that part? If I ask you, like, what is the most frequent question people are asking?
Caching.
Question, okay. Okay, and if I ask you another question, how long are usually in the last 1 month, okay, how long was the conversation? What was the minimum number of questions a user asked? Hmm?
Like model reading, like ChatGPT.
Yeah. But I'm just saying that, for example, in the past 1 month.
About the usage statistics,
Yeah.
Logging.
Logging, yeah. So you need some mechanism to log the data. Okay, that is missing in here. If you see here, we have just the index, but you don't know when people are interacting. You can also say whether people are liking your answers or not. Okay. The application needs to understand, like if you created the application and you don't have a visibility, you don't even know whether your application is effective or not. You need to have some kind of traceability or metrics that my application is performing well or not. Okay. So what I do is, if I have all this data and I just save the conversation in here, then I can do all these analytics. I can ask what is the most frequent question with the user are asking. I can optimize for that. I can create in the application to give the user an option to have thumbs up or thumbs down. If thumbs down is there, I might have responded ineffectively, or maybe the user doesn't like the question. So I should evaluate whether I have to do prompt engineering or my data is missing some question with the user asking. Okay, if you know like how many question the user is asking, you can optimize the cost of the overall service, whether you have over provision or under provision. If there is a particular, let's say, event and people are asking more question. Okay, so if you don't save that history, you will not know what is the visibility of your application. Do you guys agree? Okay, so where should I save this data? If I want to like this is a kind of like unstructured data as well, right? Where should I save it? What are the options that I can save unstructured data? Cosmos DB, yeah. Really the option is Cosmos DB because it's like supports JSON type of document. You can have timestamp and question and answer. You can create that kind of JSON, and the response of usually OpenAI is in JSON model. You can easily save it directly. Okay. So that's one thing in here. But for saving the data first, okay, if I save the data, I need to have some analytical platform. You might already have big data platform like an analytical warehouse or something like that. Usually you ingest all this data from a transactional system afterwards to an analytical platform. Okay, in analytical platform, usually like the way we do it in Azure is three. Okay, either Synapse, okay, it's like an MPP system where you can have your own data warehouses and everything. You can have Databricks, or the Synapse is now upgraded to Fabric or Power BI, so you can have that option as well. Okay, so this analytical platform, you save it to Cosmos, but Cosmos will be then linked to this service to ingest the data constantly, and you connect your reporting engine to these services. Okay, so that's the other piece that I want to cover. So if I put back the architecture, okay, I remove the vector side. Okay, this is the application that we were talking about. From this application, I say save chat. Okay, we all agreed, right, that save chat and maybe save it in Cosmos DB. Okay, from there, now I have in Cosmos DB, there can be two parts. If I want to create this report, I can directly connect report to Cosmos DB. Okay, but usually report doesn't work very well with unstructured data or a JSON structure. You have to put it in a structure, facts and dimensions. Okay, so consider that your most frequent questions are, what is the longest history of the question? You have some metrics. And for the metrics, you don't work on the raw data. You just first transform this. And this is this part that either you use Synapse or Fabric or Databricks and transform this data for reporting. So you have facts and dimension. How many users interacted with your chat in the last 1 month? In the last 1 week, in the last 1 day? What was the most frequent question in the last 1 week, in the last 1 month, in the last 1 year? What was the peak time? So all these KPIs or metrics, you will do it from unstructured to structured form. Okay, and that's what this flow is talking about. Okay, you can also say that, for example, when you are asked the most frequent question, sometimes the questions you are not like putting the exact question on the user prompt. You just put like a word cloud. Okay, you just take the data and put a word cloud on the report, and they just automatically know what is the main topic of this session and things like that. So you can do the language to detect the main keywords from those questions and put it here as well. Okay, like whether people are asking more questions on the complaints or HR policy, or maybe they are not happy with password resets and things like that, if it's something internal. So at least you will get a general idea what is the most relevant topic people are discussing. Okay, is that clear till now?
Can you just repeat?
Yeah. So what I'm saying is you have the interaction with the app. Okay. If you ask a question, you start with ChatGPT. You ask a question, it responded an answer. You ask another question, it responded an answer. Okay. Now you need to save this history. Otherwise, how would ChatGPT knows how many questions usually the user asks in one session? You need to know whether people are asking 5 questions or 3 questions mostly, or 1 question. What is the most asked question? If you are doing in your own data, there will be, for example, if you created a chatbot for internal HR policy, you want to know what are people talking about mostly for which HR policy. Okay, so that are the question. If you don't have this analytics, it will not work. Okay, the other thing is if I ask you how many users come to the session, interacted with the chatbot in the last 1 month, you want to have that knowledge. Otherwise, you will know 10 users are coming and I'm spending a lot of money on this chatbot. I don't need it. It is just serving 10 users. And if the user are giving a thumbs down, you just say, okay, I created something, but the users are not happy with my response. So either I have to upgrade the response or make it more useful. Okay, so a classic chat. Yeah, got it? Okay. Yeah, Fabi.
Question from online. What is the other service to find the intent?
Yeah, so it's language, the language one. Okay, previously it was called conversation language CLU, conversation language understanding. That is part of the language understanding, but you can just use that for intents. The classic example was like the Q&A maker. If you have used it like previously 6-8 months back, that was the service, but that is part of this service. There is a particular module which we call CLU. Okay, conversation language understanding, and you create intents. Intent can be ordering, or let's say booking a flight, ordering, happy, or something like that. You create the intents, and based on that, you take an action. You call a separate agent. Okay. Let me see. Yeah.
Is leveraging LLM.
Sorry.
Is leveraging LLM.
So good question. There are 2 parts, as I mentioned. You can do the intents in the LLM. LLMs can do the intents as well. Okay. But sometimes the LLMs will respond a little extra, like it will take a little longer. It might take like 200 milliseconds as an example, because it's a large language model. It is very big, and you are asking a very simple task. So the model which is just for intent detection, that is a very specified thing. It is responding, let's say, in 5 milliseconds. Okay, but it just works that you have 5 intents, and it will just tell you whether this question is for this intent or this intent.
Based on what?
The question you will ask, for example, when somebody say, book me a flight from, let's say, Doha to, let's say, UK, as an example. Okay, this is a booking request. Okay, so it will say that this is a booking request, and you give this type of sample example that these are the questions. This is what usually the intent is. And it will tell you that this is the source, this is the destination. If you say, I want to order a pizza, this means that order me a pizza. Okay, yeah, rule based. And if you see CLU, it will be very simple. It's a GUI based. We just give an example, it will understand. If you ask, for example, like the booking, as I mentioned, it will know the source and destination. You just say which day, it will detect the dates. Okay. If you are ordering a pizza, it will tell you, okay, what are the ingredients? Chicken, meat, vegetarian, whatever you like, it will put the ingredients accordingly. Okay.
So is Azure AI language is available as a part of OpenAI itself, or you are using?
Yeah. So this is available as a separate API, and this is available as a separate API. But there is one service which is called AI service. Okay, in which all these APIs are combined as a single unit as well. Okay. But
Internally, you are using this.
yes. No. There is separate API. If you want to use this one, as I mentioned, it will use the large language model. But the large language model is not generating something. You are using it for very simple tasks. You can do it. I'm just saying, for simplicity point of view, you can use it. Okay. But sometimes your application is latency specific as well. Okay. The large language model will not respond in milliseconds. It will always respond in seconds. Okay. Usually when you have a lot of questions, a large question will respond in 3 seconds around. And that is what humans do as well. If you ask me a question, I'll think about a few seconds before responding. Okay. But when you have a very specific task, okay, it will respond very fast, but it cannot do anything else. It will just identify that these are the 5 types that you want me to identify. I'll just do that 5 parts. Nothing else. Okay.
So for the intent identification, like given like I have like 2 statements, right? Like connect me to the tech support or get me the tech support. In this context, what should be the intent? Like how the system will identify?
Yeah. So if you give that example and you just say transfer me to an agent, okay, it will understand that, for example, you will give a question.
The agent is like the entity that it is taking, or what exactly it is looking for in this context?
Yeah. So again, let me give an example. Okay, a simple example: book me a flight from Doha to UK. When you give an example like this, you will give like multiple example like this in the service, and you say the intent of this is to book a flight. Okay, so it will understand automatically from the questions that whenever this kind of question come, it will not look into the booking. It will understand from the context what you mean, and you give like 10, 12 example or different type of questions. Okay, and it will identify that this is a booking question. Then you just say that you need to identify in this question, you will mark that this is the source and this is the target. This is the source from where you will fly, and this is the destination. And it will identify you. It will tell you the user is asking Doha to UK. Okay. And then the next question will be that you can prompt it. If the date is not there, you ask which date you want me to book, which flight you want me to book. Do you have any allergies or any specific preference for food? So you can do the chat, and that is just the chat part. Okay. But when you respond it, or you ask a complex question and you don't have that kind of just the intent identification, you then go to this one because you don't know what the user is asking. But you cannot take an action on top of it, right? Because then you don't know what the user has asked and what you are responding. It is just text-based information. Okay. Okay, till now?
Like Azure AI also will do the same function, right? Whether we can upload our own data and it can respond based on our input data.
Yeah.
And
yeah.
This is also quite similar.
Yes. No, but as I mentioned, okay, if I go back to the previous part, I covered this part. Azure AI search will just give you the index. When you search something or ask a question, it will just return you 20, 30 documents. You have to then find your own answer. But when you give it to OpenAI, it will respond back to exactly the answer that you are looking for. Okay, this just return the document. It's just a database. It doesn't have any intelligence.
In terms of the text analytics, like what it's going to do, like let's say if I have some contract documents from the 5 different vendors, like it's going to analyze like in terms of the cost and as well as the technical specifications, what is exactly the text analytics will going to do?
In here, you mean?
No, the built-in skills.
The built-in skill will just identify, for example, the built-in skill means if you have like the text analytics, okay, you want to identify that there is an image rather than text. You want to do an OCR. That will do the OCR for you. It will extract the text out of the images. Okay. In here, if you have images and you want to extract that out as like, for example, what is the object? You can do that from this one. Okay. And a translation is simple, right? You translate from one language to another. Your documents are in Arabic, but you just all want to convert into English and then do it in that runtime. Okay. So what we did till now, okay, we built the data flow till now. Okay. These are the Lego pieces which we covered, the architecture building block. We just have created just the flow now. Okay. There is one thing which I would just want to add. After this, okay, after this application, you see there's another layer on top of it. Okay. There will be an API and an application. Application means that once you create the application, this is just the orchestrator. On top of it, you want to create like a beautiful GUI and things like that. Okay. Or you want to like put it in a channel on WhatsApp or Facebook and things like that. There will be another integration layer in there. Okay. But that is just extending this part. I'm not going into that for now. Okay.
Okay.
Yeah, we will cover in the next part. So what I'll do is you understand the flow, what we are building. Okay. Now this architecture, okay, you understand the flow, but it will not go through if you are doing this work with your security or things like that. They will not probably like it. They will say, okay, give me the things that you will make it secure. You will make it enterprise ready. You will have like the DR scenario covered. So that is what Alchem will cover. That, for example, for this data flow, okay, it usually doesn't work like that. You understand the flow, but now you have to make sure that it's secure. Okay, so that Alchem will cover, and I'll leave it to him.
But first of all, those are the building blocks Share is giving you. So just make sure that you understand those pieces, because I will talk more on the infrastructure side and then give you some blocks as well, and then we will use them to create architecture. Okay. Before I move forward, I just want to know you better. Like, can you, by the raise of hands, who are coming from partners or companies that did these type of implementations before? By the raise of hands, who are coming from like company or working for a company? Okay. Who are coming from like schools or like more on the data science part? Everyone, and the rest is others, right? So that all mixed. So in this audience, like, who did some parts of basics or advanced infrastructure work before, like Azure infrastructure? Who understands what Azure infrastructure is? Okay, good. And my last question, okay? What is on top of your mind when I say Azure infrastructure in an AI architecture? What do you think? What is coming right after this one? Give me some words, like keywords. What kind of bell it rings in your head when I say infrastructure here? Because as you know, and as Sher mentioned, AI is mostly about the data and the application. So you might be asking yourself, why do we care about infrastructure here?
Integrate the subscription of the artifacts, the subnets, network.
Just, I'm repeating. One thing is, whatever you're building on top of like a scaffold, right? On top of like a landing zone, right? That needs to have a virtual network. All that groundwork needs to be in place. That's number one. What else?
Computing.
Yeah. In the end, we need to run stuff, right? We need to host stuff on compute, and we need to understand, for example, the decision, like the question Shar asked. We can have our orchestrator, we can have the application, but on which service we will run? Is it going to be App Service? Is it going to be Arrow? Is it going to be AKS? Like, what are the decision points here? Like, what trade-offs are we giving, or what are the benefits, pros and cons? Exactly, great point. What else? Identity. All right. Those components interact with each other, okay? And when they interact with each other, they need to be, so we're talking about two things. Authorization and authentication. Those are two different things. You probably heard them before, you've seen them before, maybe you don't know them, but in this context, that will be important, because when you're designing an enterprise architecture, which we are building together, that identity piece is crucial. Okay? Anything else?
Security, liability.
Of course, security in everything we do, right? But, I'm sorry?
Data source also.
What do you mean as data?
I mean, data is coming from other data.
Kind of like a layered security, like, you want to know where and in which boundary you're operating in which boundary your application is in. Like, are you having some data coming from a public network, for example, which you need to put some additional controls, or are we in a secure boundary, let's say, right? So exactly, all these what you discovered are part of infrastructure, right? And usually, if you ask me, like, in the out of battery. No. Okay, fine. So if you ask me, like, if we were to summarize all these points, and the mindset, usually infra people look at projects such as this one is kind of like a parent mindset. Okay, you will understand if you're parents or if you have kids and stuff. It's usually fun and cool to play with the toys or the AI, and then your parent comes and says, like, make sure you don't hit your head. There's a pillow. So that basically the idea here is to provide flexibility for the application and data to flow, or the application to work, but at the same time control it. Okay, but that's not only about securing it, right? So we had the discussion. It's not only about security; it's about controlling it. Which is a combination of, for example, maybe you heard this, like by the show of hands, who heard this principle before called zero trust? What is it?
So even for internal and external, everything is authenticated, authorized, all the controls in place. So like like password are split,
Yep.
Nice.
It tells by the name, right? Zero trust. You don't trust if the application is in your private network. Doesn't mean anything to you. You still authenticate. You still act like it's usually called assume breach. You assume your system is breached. And then your private network is no longer a private network, right? Because there's someone inside, right? So that's why you trust nothing. That's why I'm usually referring this to like a parent mindset, like, you don't trust, right? You still put the guardrails in place and and we will double click what those guardrails are. And by the way, if you're interested, take a, it's not Microsoft specific approach. You can read to what entail it covers, it covers like security pieces and all that. But for this session, I'll be double clicking a few of those, right? Just not to make this session security session, right? We will be double clicking on these ones. And plus, some other things as well, like monitoring and alerting, right? You set up your application, all doing well, that's fine. But how are you get notified if something goes wrong? If you don't set up a proper monitoring, a proper alerting, if something's going wrong and you go unnoticed, that will cause a business impact, right? So you need to make sure you have the controls in place in terms of monitoring, observability, and alerting. And this is usually something that is not baked into the application, but usually done by your, the IT professionals or the system team in a company you work for. So they basically, if you submit like an AI, or application design, they usually look in these pieces, and asking you if it's well monitored. What is your KPIs, for example? Like, under which threshold should I be worried about your application? You can say that, okay, if it crosses above CPU utilization 90%, it means that something is going wrong and it will crash soon. Those kind of stuff, monitoring piece. Governance and cost management is exactly as you mentioned. Everything we are deploying in Azure are in subscriptions. Okay, and subscription is nothing but a logical boundary. Okay, you can create as many as subscriptions. Doesn't matter. It's like a bucket you put your stuff in. But when it comes to share that bucket with someone or hand over that bucket, whatever you have in that goes with the bucket. So that you need to think about, okay, how I should separate the things and put them in different buckets. So one thing we do is, for example, we create Azure subscriptions per environment. Right? We have development environment, where all the Azure resources for development are put there. We have staging, we have production. So we basically limit, if something happens, we basically limit the surface of impact. Okay? If, for example, you have some shared services, you put them in a different bucket because it's shared. It doesn't belong to one environment, for example. Right? It's more on the governance part, which is really important when you see in the architecture. Because just one question, maybe, if you consume what Sharon mentioned, this flow, okay? If this application is built for one company and company only, it's fine. You don't have to make those decisions. Fine. But if you build for one company and multiple projects are using it, it is important how much of those resources are shared, how much of them are dedicated to one project, etc. So that that's one thing that usually infra people look into in terms of governance and also cost management. Right, we need to be efficient and effective. So if I'm deploying an Azure Open AI instance for a number of projects, why? I'm wasting that budget, right? Instead of that, you'd say that, okay, project one, you're using this APIs, Azure Open AI, you're using as well. So let me deploy them in a way that it's shared for you. So I only pay for one instance and share with all of you, and then maybe charge back according to your usage. You use this many of tokens, you cause this many of budget. There you go. Instead of deploying multiple instances, which is closely related to managing the cost and budgets, which is critical in an enterprise, architecture, right? Lastly, but not the least, of course, is hireability. Okay, just consider that hireability is usually a technical discussion, but does not come from technical reasons. It comes from business, right? And every application has a different hireability requirement. There are some applications which doesn't have to be highly available all the time, but there are some applications that needs to be, hireable. And we usually, measure that metrics called that maybe, SLA, SLOs, that, 99.999, like we count the number of nines after that, which means that 99 point whatever of the time, this service is up, right? And what you do is you basically try to create an architecture having not the maximum 99, but the what you need, okay? Usually, like when I have this discussions with the customers, the highest is not always the best, because when you're trying to create the highest available system, it is often the most expensive, okay? Because what you do is you deploy multiple instances of everything. Maybe you want that, okay, what if I deploy in West Europe region in Asia? What if the region goes down? Okay, let me deploy to Asia as well, right? So all those deployments are cost. So you need to ask yourself, do I need this much of availability, right? So that's often the discussion between the business requirements and the technical background of it. So each of these are like two detailed, discussions on its own, which if you're interested, we can have an offline discussion. But for the sake of this architecture, I'll be double clicking on Zero Trust. Before I move forward, any questions, anything you would like to add on the general spectrum of infra?
DR.
DR is part of this high ability, because you can have an active passive, those you can have, but again, it comes to the question, like, you need to ask, do you need a DR? And what kind of DR you like? You can have in-country DR, multi-region DR, active passive. It all comes to like thinking of how much of that capability you need, and then you basically decide, okay, which of the components I need to make high available, which of the components I keep it as like a standby in the DR region. DR is basically, for the ones you don't know, disaster recovery, okay? Which is, if a disaster happens to your primary data center, you need to keep the business running, okay? And even though it sounds easy, but it is really hard to do. Because once the system is down, you need to maybe fail over to another data center, another region to spin everything up, and then accept your customers or run your application so that you continue your business. Okay, and yeah, there's like a long discussion, but like I believe you understand at least the why of it. So let's dive into what of it. For the Zero Trust, I put here a definition, but what I would like you to understand is the pieces I colored, okay? I believe you said that, right? That every request should be authenticated and authorized because we don't trust, right? And I will tell you what authentication and authorization is. Before I do, anyone knows the difference in the audience? What is authentication versus authorization?
Authentication is who is the person that's connecting, and authorization is what can he do.
Correct, exactly. Authentication is we verify the identity. Okay, you might say, I might say I'm an Alchem, but maybe I'm lying, right? You need an authority to say that, yes, you are indeed what you are. Okay, this is called authentication. Authorization, on the other hand, is you're verified, but you have access to certain things, not everything, right? Authorization is basically verifying or determining what your account, what your identity has access to consume, read, write, update, do all those operations. Okay, those are two things. So we basically, with the Zero Trust, we basically ensure that all the flows within the architecture is always authenticated and authorized. Because of the reason I mentioned to you, right? One of the ideas is assume breach. You do this, it's maybe like a little paranoid idea, but that's it. It's Zero Trust, right? You need to look a little paranoid and then think of those controls, like, and enforce those controls. Second one is secure, isolated, and efficient communication. So even though we deploy everything in our Azure subscription, whatever, but there are different multiple flavors of deploying it. You can expose some of your components to public internet. You can keep them private, or you can expose with some controls, like all different flavors, right? So the idea that we are trying to go to here is we want to make it isolated, but without compromising any functionality. Okay, it will be secure, it will be isolated, but still give the functionality it's supposed to give. But this is basically the idea of Zero Trust. So what are we going to discuss here is the network access rules, exactly what I mentioned, right? You can deploy, for example, any Azure PaaS service, fine. But how you access that is a different story. You can access publicly because those PaaS are basically deployed not in your virtual networks. They have a public name, they have a public IP. If you put it in, you can access. That's it. But again, in an enterprise architecture, do you want that? That's another question, right? So there are different rules, there are different flavors you can set. We will click that. Microsegmentation, layers of the defense, and we discussed the authentication authorization. So what I mean by network access rules. Okay, let me rewind this back. If you deploy any Azure PaaS service, in this example, I deployed Azure Open AI, okay? And if you go to the networking tab, okay, it will basically ask you a couple of things. And by default, the default setting is there are no network restrictions applied, which means that it is accessible over internet publicly, okay? But there are different flavors. And those flavors are, as you can see here, in the networking, allow access from all networks. Okay, doesn't matter, like, from internet, etc. You can use to select your own networks and private endpoints. We will come to private endpoints, or you can disable the access. Okay, so, and before we start, I can tell you there's no right answer right now. Okay, you can choose, different choices here, but as part of the enterprise architecture, we would be going to the green one. You might be asking, like, it's disabled. How are we going to access? I'll come to it. Okay, but I'm giving you the other options so that you know. So the first one is you basically, or let me draw this. That would be better. Question? What?
Video is not green.
Video is not
For this one.
Yes, they cannot see it, so it's better to use the whiteboard if you're gonna draw something.
Here.
Yeah, on the, maybe just slide maybe. Or use the.
I think that no worries. So I just want to understand this. So we have a concept of virtual networks in API. Who knows about virtual networks? Those are basically private spaces that belongs to you, okay, as a customer. So when you deploy a virtual network, it is your network, it is your IP address, and you can deploy the service in that network, which means that if I am in that network, I can access those resources. If I'm not in that network, I can either access from internet, if you expose it, or not. Okay, so that's why when we deploy things in Azure, there needs to be a network. Okay, that's a virtual network. And each virtual network has subnets, which you can think like, we have a virtual network and inside that we have subnets, okay? And when I deploy an Azure PaaS resource, that resource is not deployed in your VNet, in your network. It is deployed somewhere else, okay? So the question is, how am I going to access this resource within my network? So this option basically tells that. What you can do is each Azure resource has a firewall, right? That firewall says, who can access this PaaS resource. You can say that, okay, this resource will be accessed over internet or from the VNet networks I specify, and then that's it, right? You basically whitelist the things, the areas that can access my resource, okay? And if you do that, that's basically there's something called service endpoint created in your subnets, which means that if traffic is originated from that subnet, it can only contact the PaaS resource. Example, Azure Open AI, right? You don't want to expose your Azure Open AI and the APIs to public internet. Okay, you need some control. What you can do is, with the setting, you can say that only this subnet or only requests coming from this subnet can consume my Azure Open AI. Okay, this is optional.
Can I add a few points here? in the previous architecture when I was showing, you remember when we were indexing the data into, let's say, the database. Consider you have indexes your policies or your private data into a knowledge base. Okay. Now, if you enable everything from all network, okay, you will still require authorization, okay, and authentication. But consider that we don't trust it, right? You go home, you connect it to Azure, okay. If you can connect from all, you can download the data to your local machine. A corporate will not allow that, and we don't trust anyone. So what we are doing is you should be disabling that and just saying that when you are in the particular network, like in your own organization or your own thing, it should be only accessible at that time. The second thing is with Alchemist showing here, OpenAI, like we were discussing that it's a stateless service. Why would we like to protect that as well? Any idea why would you protect? Because it's a stateless service, so there is no data leakage. So why would you protect it?
Compute.
Yeah. So consider that you are my friend, right? You are working in, let's say, a company. You give me the key. I just go build my own application, and all the cost is coming to you. Okay. So that's the reason why this is important.
Yeah. But there's a catch with this. Okay. When you whitelist one subnet to talk to this Azure OpenAI, you only whitelist that subnet. Again, right? So, but imagine in the enterprise architectures, you might have your on-prem talking to your Azure OpenAI or other networks and other subscriptions. So are you going to whitelist each and every subnet? That's not effective, right? So it does the job for sure. But when we are looking at like a bigger implementations, you need to think of multiple kind of scenarios, right? That's where the service endpoint option falls short. That is the reason. Is it delay or maybe
Sometimes like
maybe the battery is low?
yeah.
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 You went too far?
Mhm.
Yeah, that's fine. That's why there's a concept. Just remember this, okay? There's a concept called private endpoint. What private endpoint is, I will tell you like this. You know a VM, right? Like a virtual machine. There's a virtual machine, and the way this virtual machine is a member of your network is by using something called network interface card. Okay? This network interface card is plugged into that VM, and this one leg is in your VM and one leg is in the network, right? Like a bridge. That makes the VM talk to your workloads and whatever you have in the network. Imagine we are doing the same for Azure PaaS resources. For example, OpenAI. Does that have a network interface card? No. But with private endpoint, we make it. Okay? So what we do is, again, in that subnet, instead of saying that all the traffic from this subnet is allowed on the Azure OpenAI, we say that we deploy a private endpoint of Azure OpenAI in that subnet, which is a network interface card with an IP of your network. So looking from network perspective, it is no different than a VM. Okay, you're accessing privately, you're calling that endpoint privately, right? You can put all the controls you like. And since it's an IP, that IP, as long as it's routable, you can ping that IP from your on-prem, from different networks, so that it gives you flexibility. Okay, but on the con side, you need to implement it. Okay, it's like not complex, but more complex than the service endpoint. You need to basically deploy an endpoint. You need to manage the IP, the name resolution. But this is the way for an enterprise architecture to be secure, to be isolated by giving those flexibilities. So what we do is, for all the PaaS resources you see in the design and what Sher mentioned, we basically deploy private endpoints for those to communicate between each other.
It's an extra layer of security over the VNet. So so we had the OpenAI. Instead of being able to access, we just close it completely and can only be accessed via the VNet. And we use
Not via the VNet, via the private endpoint. You have the private endpoint.
in the VNet.
Exactly. You plug that private endpoint in the VNet, right? And only path to that resource is through that endpoint. And besides all that, you block. For example, because that private endpoint is not in internet, there's no internet access, right? So because that private endpoint is not in another network, there's no access unless you configure it. Okay? Fatih?
There is one online question. Abdul is asking, is there any plan to make disabled public access default, or can we do it that using AZ policy?
To make it default, disabled as default when services are
Defend the
default.
resource, it's by default disabled.
As far as I know, with policy, no, you cannot. But usually, once there is a like an architecture, when you think about how you will deploy these resources, you feed this configuration in the deployment. Okay, so once, for example, Azure Open AI is being deployed as part of the architecture, in the design, everyone knows that it will be deployed with a private endpoint. Because you need to plan for it, right? Because you need to think of this IP, in which subnet is going to be, right? Is it going to be in a production subnet? Is it going to be in hub or whatever, right? So all that needs to be designed first and then fed to the deployment team, so the deployment team deploys with this configuration. But coming to that question, if it's deployed with the default setting and you want to set this to private endpoint, with a use of policy, as far as I know, it's not doable. But after you deploy it, you can do it, right? So that you can deploy Azure Open AI, and then maybe you forgot creating an endpoint, then you can come here, networking, you can go, you can, do I have this here?
It's on the previous one.
Yeah, but there's an option to deploy, add a private endpoint so that you can add after.
Yeah.
That's fine, you will find in the portal that you can add later.
And also added during the deployment.
That's my point. Like the preferred way is to do it with the deployment, during the deployment, right?
I'll give one question from my side.
Yeah.
If, for example, there is a user, we don't trust anyone. Okay, let's say I have access and the deployment was disabled. I have access and I enable it. Can it be monitored? Can be alerted that, for example, somebody has changed the configuration?
Of course, but usually as the application people here, we're not concerned in that. So usually what happens in the background is all the logs, all the activities in Azure are logged. They're called Azure activity logs. So for example, if I create this configuration, who created it, when, what he or she created, it's called audit logs. So if I'm deploying this architecture in an enterprise, there's someone monitoring these activities and might be asking, what are they, right? But what we want in enterprise setting is, I don't need this to say, but it's something called least privilege, the access. Maybe you heard RBAC. So even as an application person, for example, you shouldn't be authorized, remember, to do this change, okay? Because this change is something fundamental and changes how the service will be consumed and should not be changed by people who are not supposed to change, right? But if, as Sharon mentioned, even if you have the permission to do it, can you do it? Yes, you can do it, but that log will be, more. Exactly, yeah. But they will not, you won't be able to do it anyways in the start. Good. So I give you two Lego blocks. I'm sure you understood, right? One is using Azure Private Link, private endpoints. The other one is Azure Service Endpoints. Just one sentence recap. This one is the one that you deploy a private endpoint. This one, Azure Service Endpoint, is the one you whitelist a subnet to talk to. In the architecture, you can use both of them. You can use one of them. Up to you. Okay, I'm giving you both of them.
I think multiple subnets and connect them to the endpoint, because one of the problem is that if I want to whitelist multiple subnets, I have to go one by one. Is there a way to group them together and then I can just whitelist all of them together?
No, but if you have such requirement, then it's better to consider private endpoint in the first place, right? If, for example, if service endpoint is rather simpler, right? If you want to do a quick POC, for example, right? You don't want to deal with creating an endpoint, name resolution, DNS, and all that stuff. If you don't want to deal with it, you can be, and still want to be somewhat secure and controlled, you can deploy the service and do this service endpoint so that you can select, okay, this subnet and that's it. But that architecture won't be able to evolve to meet enterprise requirements, okay? Because when you deploy it, probably they want to consume this service from on-prem, etc., and then you will fall short. That's why, that's what I'm saying. In the design, you need to decide who are consuming these services. What are my requirements? So if your requirements will be, we are deploying this as a POC, but then it will extend, then the quick decision will be, okay, forget the service endpoints, let's do private endpoints. So in the microsegmentation, I'll just speed up a little bit, okay? The three things I want to know. And this virtual network is what we discussed, right? This is your virtual network, and you have subnets inside the virtual network, okay? And what microsegmentation says is, whenever these subnets are interacting with each other, talking to each other, okay? That communication needs to be controlled, okay? Needs to be, I need to understand, I need to control on which IPs are talking to what, on which ports, or are they allowed or not? So I just draw here like a basic virtual network, okay? Imagine that maybe you deployed your Azure Open AI endpoint here in the subnet, okay? And you maybe have your application here. If you don't put any controls, this will talk to this without you even knowing this, right? Because there are no controls and they can talk, transparently. What do I do to make this more controlled? I have three things. Number one, I have something called network security groups. These are associated to subnets. What they are is basically simple access, like deny or allow list. You basically say that if a traffic is coming from this IPs on this port to this destination, allow. If this traffic is coming from that to this, deny. That's it. Basically access list. Okay? This can be for two ways. Traffic leaving the subnet or traffic coming to the subnet. You can have two different types of rules. We do this to ensure how and where the traffic is coming from. For example, if I anticipate that application will come to subnet B, I only say in this security group, allow only traffic from this subnet, and by design, by default, deny everything else. Exactly, because you are not expecting any traffic, right? Only traffic you are expecting is from this. So you basically make it tighter, okay, by the NSGs. Number one. Number two, okay? So the firewall is actually used to do two things. One is additional security in terms of like threat intelligence, like all those security flavors. I will not go deep, but the Azure firewall is used to make that communication and be in the middle to make that communication more secure. Number one, and number two, for the visibility, right? So when you look at the firewall logs, you instantly understand and see what is talking to what. You have full visibility of everything. That's why imagine that all the networks you have in your environment is always passing through a firewall. So when you take a glance at the firewall, you completely understand, okay, what is happening in my system? Like, think like like a traffic, police, having the, or CCTV, looking all the roads and highways and stuff. But the question, how do I make this happen? How do I send all the traffic? Because remember, I want to talk from A to B. How do I send the traffic through the firewall? Anyone?
Network rules application.
What else?
UDRs.
UDRs. Let's see if it's correct. Yeah. So what I do is, this is called route table, right? It's basically like a resource in Azure that I associate per subnet to say that, for example, this one. Let's impersonate it. If my traffic is leaving from subnet A to B, route table intercepts and says, if you're going to B, your next hop will be the firewall. Okay? It overrides and routes the traffic to firewall. And imagine if all those route tables are associated to all the subnets we have, we make sure that always firewall is hit and then the destination is hit. Okay, so that's how we enforce the macro segmentation. And before maybe you ask, having NSGs and route tables in each subnet is something you can control with Azure policy. Okay, for example, if you forget associating them in your subnets during deployment, for example, you can make that happen with some, of course, custom, solutions by using Azure policy. Okay.
Just to add one thing again. We started from AI, okay, but we are covering this because a lot of time data scientists application, they struggle with making sure that the application passes through a security layer, or they don't have enough information to make sure, because I feel when I talk to a lot of people, they don't understand. They have the understanding how AI works or how I can create a model, but they don't know how to make it secure. And the application doesn't go through. They cannot pass it. So that's why this information is very essential, that you can explain that, for example, to your security team that I'm doing it, but I know what I'm doing and I'm making it secure. So if you know this, you will be able to convince them.
Because most of the time, exactly, Chef, like if you are trying to deploy or submit this architecture for review to security team, they often come with you asking, like, what is the communication metrics? Like, so whatever it's called. The reason is they want to set appropriate rules on the firewall so your communication is allowed. They want to set those IPs in these NSGs so that they're allowed, but nothing else, right? So they just want to make sure that only the things you require in your application are allowed and the rest is denied. Why? Remember, zero trust, right? We don't trust anything. Whatever you told us, we trust, but the rest we don't trust. Okay? That's big. So it's maybe you will not be the ones configuring these, but it's good for you to understand, where this is coming from. What is the reason of all this infrastructural pieces?
I can just let you know we are 724.
Yeah.
One thing that we are saying about the zero trust, but by default the setting is all public allowed.
Yeah.
Why they didn't set it to disable and then we decide.
Zero trust is not needed for every scenario. Okay. Like, for example, if you can do trivial deployments and you can just test out things, you don't need to be zero trust. Okay? So if you are deploying something in an enterprise scale, you should consider the zero trust principles and you should allow. But not all the deployments in Azure require to be enterprise grade or super secure.
Okay.
So 3 more building blocks I gave: Azure Firewall, NSGs, and route tables. For the layers, so you might have, we looked at one virtual network, okay? You might have multiple virtual networks. And they have a meaning, right? Why you have virtual networks, multiple ones is, has a meaning. Because for some virtual networks, you might have enabled public access. And for some, you don't allow public access, right? For example, the whatever deployed in the VNet can be reached by internet, but not maybe this one, okay? And we call this structure, maybe you heard before, something called hub and spoke. Did you hear that before? Hub and spoke. For example, this is usually what we call as hub. And if you know the terminology DMZ or demilitarized zone, like this is basically the zone between your precious resources, internal resources, and internet. It's kind of like a middle area. So that's why whatever you publish to internet or whatever you access, first it is accessed from here and then to your local labs. We call them hub and spoke, and there can be multiple spokes. Okay? And on the hub level, there are 3 things that you can use to secure your application. For example, you deploy your Azure Open AI application, whatever, and your front end is deployed, and your front end will be used by external users, right? Which are coming from internet. Okay? You need to make sure that whatever the traffic is coming from is legitimate, secure. You need to basically take those controls. And we use these 3 services most of the time to make sure those inbound connections are secure. This one takeaway for you, the most used feature here would be something called just remember this called web application firewall. Okay, that web application firewall can be deployed on an Azure front door, Azure application gateway. What it does is it basically has a database of like known attacks called OWASP. We call them OWASP rules, like botnet rules. For example, if I'm coming from from a botnet attacking your application endpoint, this web application firewall will notice that and block the traffic, for example, right? So that's most of the time the first layer of security in terms of network security. Okay, and we deploy those features in the hub. Okay, we don't need to deploy that in the spoke. Why? Because they doesn't have any public access.
Again, one question, is the in and out, can we control via the hub NVAs? Hub NVAs, like Fortinets or gateway, like the
I didn't understand the first part. In and out?
in and out traffic?
Inbound and outbound.
Yes.
Yes, you can. What we usually, prefer is to have one firewall set for inbound traffic, another set for outbound traffic. Okay, to segregate the different traffics. But of course, you can have a single firewall to do both. But usually, in big organizations, the inbound firewalls and outbound firewalls are separate. Okay, so I gave you front door, application gateway, and DDoS protection. Okay, and just keep in mind, they are the things that needs to be deployed in the hub to publish my application. I think we pretty much touched base on this one. Okay, like the difference between authentication and authorization. The importance in this one is, I will not repeat the whole part, but we have different Azure resources, okay, deployed. And whenever they're talking to each other, okay, we need to understand that this communication is, something that we expect and something we know. And what we usually do is, to use something called managed identity. Have you heard of managed identity before? Okay, so managed identity you can think of is the identity of the service. Okay, so whenever, for example, Azure Open AI is going and fetching something from, let's say, search service, the context of this communication is within its own identity. So it says that remember we said that authentication is something like, need to prove the identity, right? We need to prove the identity first. So once this communication happens, what happens in the background is Azure Open AI goes to our authority, which is called Entra ID, and says, I am Azure Open AI. Okay? And first of all, the Entra ID verifies that really you're Azure Open AI. Fine. Authentication is done, right? And if this managed identity of Azure Open AI has or defined access on the search service, which is authorization, then it can access the service, the search service to do operations. Okay, this is basically called like authentication and authorization, one by one. I would just put here three scenarios, like three common scenarios, how those managed identities can be used, accessing what. For example, Azure OpenAI Service Access. Remember, we had this application, right, running an app service. App service has its own managed identity. Okay, when it's talking to an Azure OpenAI, another service, it talks to that service by using its own identity. What is the reason of this one? Why do you think we do this? Yeah.
In some cases, we use username and password. For example, we
Exactly.
use username and password, but you don't want to do that and keep it.
Why I don't want to do that?
Because, for example, if you want to block the request from everyone except the service itself. This is the worst way to trust no one except whoever needs to make that.
If I put the username and password in a secure file and each time you access, you can read from it, would that work?
It's better than leaving it in the code, but still someone can be able.
So there are multiple flavors. What, for example, you can see is using API keys, okay? You need to access and consume API with a key, right? And you don't put the key in the code. Option one is you can put that key in a secure, let's say, like a secure box called Azure Key Vault. It's encrypted. And each time you're calling the API, you fetch the key from there and then call it. Option one. Option two is if you don't want to mess with keys and stuff, right? You can use managed identity. right? With the managed identities, the identity itself is a credential. Okay. I will leave this to last. Okay, perfect. Do I have anything else? Fun part. So the blue ones are the infrastructure-related building blocks. We talked all of them. Okay, for some of them, you might not have the full idea, but at least if you understand what they mean and how they're used, that's enough for me. Okay, so then we come to the point that it's about the battery. Doesn't do it from here, but from there it does. So, an activity that we can do together. Okay, so those are the building blocks Cher mentioned and I mentioned. Okay, and we gave you some hints about what the architecture will look like. What it will look like is it will probably have something like a hub, right? Because I want to publish my application to internet, I need like a layer, which is like, like a secure layer. I will have maybe like another spoke where I will run my application, and maybe another spoke where it will host my AI services like Azure Open AI, maybe like, other, open source AI model service can be deployed there, which I can consume. But think of those three building blocks at the moment, okay? And then maybe we can do it like, together. And then we need to identify which one will go where. And of course, this is a generic, like, for example, I will give one of them, private link. Private link should be enabled regardless of all, right? It's generic, okay? So I will help you do that. But I need you to tell me which one goes where. Azure Private Link is generic. What about Azure Service Endpoints? Do you want to use them or not? First, let's decide on that.
If you're using private link, one of the others.
That's the question.
I don't know.
If I'm using private link, do I need to use service endpoint? No. You can, but do we need?
Sometimes you do.
Depends on the use case. Depends.
For example? You're right. If you can elaborate, like, we cannot come up with a use case right now, but you might have a private endpoint to one virtual network, but still maybe allow some communication from other subnet, which is fine. Maybe you don't want to mess routing this traffic to this endpoint. Maybe you just want to accept traffic from that subnet. It can happen. But usually, when we have the enterprise architecture, we know where the traffic is flowing, right? So that if I have a subnet where I'm accepting the traffic from, I usually deploy an endpoint, right? I usually do not go with service integration. I go with a private endpoint, okay? So, long story short, if you have the private endpoint, you might not have a service endpoint, but you might as well. My suggestion to you is go with private endpoints as much as you can for enterprise scenarios, but consider and remember that it takes kind of like a planning to deploy them, but service endpoint is not. It's easy, okay? More simpler. So I'm just leaving here. Azure front door. Yeah. I will challenge you. I know we are a little over time, but no, it's not in the hub. It is before the hub. Why? Who knows why?
There's a global service which will be distributed.
Global service. It is not in your hub. Okay. What front door does is you can imagine like that. We have POPs, points of presence, like data centers where you go internet. Okay, when you dial internet from here, your communication goes to one data center where you talk to the rest of the networks. That's called internet, right? Basically. And what Azure front door does is it is deployed on those POPs, points of presence. Why? If you have, for example, an application with like a media files, like large files, okay? You don't want each time your users to come and fetch from your, whatever. You want to bring those static content closer to them so that your performance better. And we do it by using what? CDNs. One part of Azure front door is CDN. number one, in Pocket. Second feature is something I mentioned. It's web application firewall, right? You can enable web application firewall on the front door. The benefit of this is the traffic can be, or malicious traffic can be mitigated even before it's coming to your region, in your hub. It's mitigated like those botnet or bot attacks, like they're mitigated on the points of presence before it's coming, right? And another feature is, for the high availability we discussed, it is also a load balancer. So if you deploy your architecture in two different regions, putting an Azure front door in the middle makes sense if you want to do active-active, so that front door load balances the traffic between those two regions. If, for example, you deploy one in Asia, one in Europe, if I'm coming from, let's say, India, it makes sense to consume the application from the Asia deployment, right? Front door does that. Okay? That's why I'm putting it, in front of the hub. Azure Application Gateway. In the hub as well. What about Azure Firewall?
In the front door?
Right?
Is it in the front door or in the hub?
No, it's a different service. And most of the time we use, remember, this Azure Firewall to be kind of like internal firewall, right? Kind of like if I'm talking from here to here, I always go through the firewall. Okay?
There was like that you said about that was in the front door itself or in the.
Yeah. It is called web application firewall. Web application firewall and Azure Firewall are different things. Okay? Web application firewall only, inspects the layer 7, the application traffic. Does not understand the low levels of like the OSI layer like traffic, but Azure Firewall does. Okay? It's basically like a traditional kind of like a firewall, and we use this in our design to inspect the internal traffic. Next, network security groups. Exactly. We want to attach network security groups to all the subnets, regardless of hub or whatever, right? We want to control the traffic. Azure Open AI. Why?
An AI service.
Tell me, what is the benefit of deploying Azure Open AI to here versus here?
But here we will deploy it from
You said direct interaction from outside.
There's no direct.
The both of them are private networks. So this is the app, which is the app service, like all the AKS or whatever is deployed here, and this is the AI services. In the design, it shows like this should go here. But why? Why not with the application?
Maybe segregation
Segregation might be consumed by several applications.
Yeah. You remember what I mentioned in the beginning of the session? It is to be effective. And if I'm going to have multiple applications, exactly, but all the applications are sharing my Azure Open AI, do I need to deploy Azure Open AI for each of them? No. I deploy it here and share it. That's why it's different per use case. If you have, for example, one application, and do not look forward for sharing this, you can deploy this here, which is fine, by the way. But again, for like enterprise, like multi-project kind of scenarios, we prefer to go here.
Yeah, and there is one decision why we put it in here. Azure OpenAI, as I said, that there will be two flavors. One is the pay-as-you-go, which is not that costly, and one is the paid one, which has GPUs. So you cannot have GPUs for each and every application, okay? Or otherwise, if you have a lot of money, I'll be willing to take all the money. But from your enterprise, you just want to have like the large compute in here and then shared with multiple things. Because if it's like the GPUs allocated, you want to use the same GPUs for all the application.
Yeah.
Okay, so that's one of the reasons we have separated it.
I think one concern, I think OpenAI, they updated it recently, so it's not an issue anymore about the cost. If I want to know which application is consuming what.
Yeah, so this we will cover in architecture as well. Yeah, so Alkim can cover that. We will cover to that, I think, in a minute.
Have you discussed about APIM in the previous sessions?
No, we just like did a high level, and I told that all the application needs to be covered with the API.
Yeah.
But I think the people should know.
In maybe one sentence. What Azure API management does is it basically hosts your APIs. Okay. And as you remember, Azure OpenAI is nothing but like APIs. Like, if it's text completion API or embeddings API, we do API calls. If we want a better control on the API calls, such as rate limiting, throttling, or maybe for cost. Like I have multiple projects. Who called or how many times that API was called by which project so that I can maybe charge back. Those controls, they are not natively in the Azure OpenAI. But we have those in API management, right? So that we basically host those APIs on the API management. That's why usually API management goes together with the Azure OpenAI.
And there can be different debates. We will just put it here and then I'll explain it later on. But what we are doing it here for the Azure OpenAI service, we are creating the API app. What Abdurrahman was asking is that, for example, the cost, throttles and things like that, consider you have 10 applications. You want to manage that the GPUs are used in such a way that the application one can only use 10%.
Yeah.
The other one can use 20%. The other can use 30%. So you can manage that and charge that back the application as well. So that's the pattern why we are putting it here.
Maybe we didn't mention, but in API management backends, there can be multiple Azure OpenAIs with different flavors. One Azure OpenAI can be PTU, which is like a fixed capacity, and the other one can be pay as you go. So you can have flavors of, for example, if you reach the usage of, let's say PTU, the Azure API management can take a decision to make the pay as you go available during that, so that you continue your, business, kind of like a high availability scenario.
API management, we can keep this in AI application as well. Like for example, I have some APIs which are hosted on Function app.
Okay.
So I can keep the API management in AI application, which are crisp. So that should be closer to my Function app where I'm hosting my APIs.
It can be, of course.
Yeah.
But just like a one catch here, you can have an Azure API management which hosts all your application APIs.
Yeah.
Fine. And maybe there is something like additional capabilities introduced for the Azure API management called AI gateway capabilities, right? Those AI gateway capabilities are specifically for Azure OpenAI usage scenarios. For example, because in your traditional applications, you don't need that, cost chargeback and stuff like that, right? That's why sometimes it might make sense for your applications deploy one APIM, and for AI deploy another APIM. And that another APIM will be kind of AI gateway APIM. But technically, you're right. You can host all the APIs in a single APIM, and it can scale. It works. But for granularity and modularity, different APIMs make more sense. Managed identities. Where do we use them? Like in a specific place or generic?
Generic.
Yeah. DDoS protection. Yes. The orchestrator here is what Sharon mentioned. Remember the app. It can be an app service. It can be ARO. It can be a CAS. Where do we usually deploy that? Yeah. Cosmos. What about route tables? I will not discuss this for now, but if you have any questions, like after the session, I will be available. For Power BI?
Just to add, Power BI. Power BI is like a SaaS service, right? It's like in Office 365 tenant. So although we are just saying that it's part of the application, but considers the gateway that connect the SaaS service of Power BI to this application on the Synapse part. Okay, but this Power BI is not actually like a service which you create. It is already available to your Office 365. It is not a service like that. But if you are talking about Fabric or things like that, which I was seeing in the compute, MVP compute, you can consider that we are talking about that here. So you can put it in the application. I just want to make sure that people don't think that we don't know what we are talking about, but it's just to understand.
Yeah. The last one, Synapse.
So it can be two things, right? Usually in the application, I also segregate it into two parts because a lot of time Synapse will also be like a common service, which is taking a lot of data from your on-prem. It might not be just for the application layer. You are just creating a warehouse. You are creating things like that. So it can be put in the application layer, but it's actually maybe create another spoke and put that warehouse in there that multiple sources can connect.
Yeah.
But consider that the application has another application. This is the warehouse application that we are talking.
Maybe a different spoke here, like kind of like a AI. You understood how and why we are making this portion shared, and similar to what Sharon mentioned. consider another spoke, a shared data warehouse solution, which multiple applications will benefit. And maybe like, the synapse will go into that spoke. It will be better, making more sense, right?
Can we go to the last infrastructure one? Because there was a few things I want to show that, because in the end, once you understand this, this is the architecture, okay? We will just make it a little bigger. There will be a few things, okay? Just focus on the top part, okay? In here, you see the warehouse pattern, the analytical pattern, which has a data lake, okay, the storage accounts, okay, and the compute for all your data warehouse or data lake type of concept. You can change this with Databricks, Synapse, Fabric, that is the analytical platform I'm talking about. For all your reporting needs, so you can just put it here. And you see this Power BI gateway. Power BI is a SaaS service which cannot connect to anything private. So you need to have an agent which then Power BI can talk to this one. So this is like the whitelisting type of mechanism. Okay, so that is why it's put here. And then the AI application, if you see RAG means like the chat with your data type of scenario. We put all the application, the AI search, the cognitive services. Cognitive services include the OpenAI, the storage account where we were putting the raw files and everything that is in here. There is another storage and this is another storage. And the keywords, if we are creating like secrets and things like that, in here you see the Cosmos DB, which was saving the data. Okay, and this, like if you remember, Elkin was mentioning that we have to enable the communication. And I was saying that the chat with your data, when you save it, you have to make it available to this service. Okay, so that communication needs to be enabled. Okay, that's how you do it. And then the application part, consider that this is your internal application. Internal application, you just keep it here. Don't open it to anything outside. But if it needs to be open outside, then you have to go to the hub, the firewalls, and the gateways and things like that. Coming to this part, okay, we have separated it in a different way. Now, what we are talking about in OpenAI, you can have one, for example, like a PTU, which is a dedicated GPUs that is available, okay, and then you have pay as you go, maybe in different regions. Okay, there is always a token. If you remember from my first session, there is always a limit on the tokens. You remember there was 8,000 on the embedding, 32,000 maybe on the completion, and there is always a limit for per minute, how many calls you can do per minute. So consider your application is high, needs to be highly available. You don't want to give a user that you have to wait for a few seconds or something like that. So what you do is you just still respond back to the customer, but a little delay. You have like a retry logic. If it doesn't work, you just fall back to this one. But if you handle that switching in your application, you have a lot of application code. So you move this one, these two into the API, okay, and do the routing there. For example, like if one service is not available or if it's giving you 429s, then you can automatically do that in here. And then we have added something else. You have the embedding models as well, okay. Now consider we were also discussing, I'll cover it in the next session, the last session. Consider you want to use Llama or Mistral or let's say Phi. For that, you might require, like there is two versions as well. One is the PayGo and one is the GPU deployment. So you might require GPU specifically for that to deploy. You might bring your own compute, okay? So that will be something like here, which we are trying to finalize this architecture, but you know the gist that why we are creating this in here, because you might have multiple models that you want to do. It might not be available just from one service. Okay, and then all of this for the throttling and everything, you just create the API, and this is the chargeback. Consider that you will have like the API, and then you have a report which application is using how much. If consider you have like you are a service provider, okay. Consider Microsoft, how they are throttling it, how they are charging it. If you are using the pay as you go, how Microsoft is charging. For each call, they are calculating the thing. So the same thing, if you want to do it internally, you have to do this kind of mechanism, and you do a chargeback. So we have a Cosmos, which is showing the data, and then like Power BI, but the Power BI is actually giving the data to the analytics. Yeah.
Question. I haven't tried the new API for OpenAI specifically on APIM. Does it work by providing an API key for each project or?
This I have to check, but I think we can define products. I think the APIs usually are for products, and then you just manage accordingly. But I think the keys will work as well. I don't remember because you just give a token. You give an identity whenever application is calling, they just give their own identity that I am this application, and then you just do that in here. But if it's a product, then the product automatically know that which products you are calling about.
Yeah. Just maybe you done, Jen?
Yeah, just want to check. Does it make sense why we have like split it in here? And then like,
Maybe just like a quick run through, like, this is the architecture, okay? Like I will just try to maybe do it better here. But like if I expose my application like chatbot to internet and people come and, use the app, how usually it works, the traffic works is first it will hit the front door, okay, as we discussed, okay? And then it will come to our web application firewall. It can be on the front door or separate, but again, it can be like this. Then it will pass through my firewall and then go to my application here. Okay, this is number 4. And this is the piece, I will not go one by one, but you understand, right? This is the orchestrator. It will first go and, check with the AI search to find maybe like, vectors, etc., and then go and call, over the internal firewall to this APIM, which hosts the OpenAI, APIs. And then, so all the flow here, I will not go in detail, but like, we labeled it, okay? Like, 4 or 5, so that you can see, I believe there was a question like in how the end-to-end flow works in the architecture. This is architecture, and those numbers basically represent how different components talk to each other in terms of networking. And just keep in mind that these the blue area is the virtual network we discussed. The gray pieces are the subnets, and we have the UDRs, the route tables, NFGs, everything we discussed existing in the architecture, so that you bring the pieces together. So I think we have a couple of minutes remaining. If we don't have anything else, we can.
Yeah, I just want to check that we will get this kind of architecture with the documentation on the GitHub. But when you read that or you want to deploy it, at least you will know why we have made these decisions. Okay, this is just a blueprint. You can take the decision based on this, but we are just providing guidelines that what we recommend or do something like this. There is a question, I think.
This is about your part, the first part that you explain about LLMs. How can you set data boundaries according to different profiles? For instance, how would you ensure that HR department receives a different response compared to the finance department for the same query?
So this is like, for example, maybe I need a little bit more information. But consider if you want the HR and the other department to have the same, if they are asking the same question, you want to respond in the same way. You don't want to trick them. Okay? If the knowledge is the same, the answer should be the same. The meaning of the answer will be the same, maybe the wording is a bit different, but that is like the information. Whenever you ask a question, let's say, what is my HR policy? If the HR team is asking or the marketing is asking, if your facts or your knowledge base is the same, the answer should be the same. Okay, the semantic meaning should be the same.
I elaborate more on this question, and I think I'm not sure if I asked the same question last time. So now end user is asking a question, okay, and I need to like something in the middle that will understand. Okay, this is an HR question routing to the knowledge base of HR. This is an IT question routed to the knowledge base of IT service management tool.
Yeah.
This is whatever facility management question routed to the LLM of.
Yeah. So there is multiple ways to implement it.
It's about the routing part.
Yes. So there is multiple things. Consider that you have like one scenario, you have all the knowledge base in one large depository. Okay, that is one thing. When the user asks a question, if your scenario is such that one department cannot ask a question about the other department, okay, what you do is you pass for your actual question, the user who is, because you need to authenticate that you are from this department or you are from this department. And the application need to pass that token or that in the search query that I only filter the data based on this tag and then check what is the similarity of this. So you just segregate it in here. The other thing is like, for example, if either you identify the intent first and then like have multiple knowledge base, but if you have the same knowledge even, you can identify that this is this department and you just put a tag in your like knowledge base that this tag is for this department, this tag is for this. So when you query it in the similarity metrics, you only retrieve first the documents which are for that department, and then you find the similarities, not in everything. So even if the HR is asking a question maybe for finance, okay, the knowledge will be empty. They will say, oh, I don't have the knowledge about this, or you are not authorized to ask this question. This is the application part. Which
also like something to do with the data governance and like purview and capabilities as well.
Yeah, there's different things. Okay. The team
Like we have like the chat response is different, and as well as we will use the managed identity or the service principal.
Yeah.
Like in terms of if the service principal is going to expect, how we can as a whole architecture we can.
So monitoring is multiple part, right? Like we discussed, for example, if something is happening on the service you want to monitor, or you want to see that the usability of the compute is going out or something like that, the security controls are there. So everything is logged. You have to enable the logs because the logs will cost you as well, right? You just manage it and then you put alerts rule. If the service is giving like above that or like a threshold, this is around the service level. But the other thing can be whether my response is good or bad. This is something which the monitoring tool will not give you, but you in the application logic, you have to say, somebody have given a thumbs down response, I want to monitor what was the response. And that's why we save the history to give that response back.
The infra monitoring is about how performant and how good the pieces are working, right? They can work still well, but give you maybe undesired, responses in the app. That is monitoring, but a different kind of monitoring, which you need to, more on the application side, like.
Yeah, I think we are done. Pizza is going to.
Yes, I think let's go and discuss more on pizzas. Thank you, whoever joined on the online.